Welcome to Technically You, the podcast where we decode the infrastructure powering tomorrow's connectivity. Today's topic, fixed wireless technology, a growing contender in the broadband space, especially for rural and underserved regions.
Yeah. And unlike mobile wireless, fixed wireless is all about point-to-point or point-to-multipoint connections, delivering broadband without digging trenches or laying fiber. It's fast, cost-equitable, and highly scalable when deployed right. Let's start with what fixed wireless technology is.
Fixed wireless refers to broadband internet access that is delivered over the air from a base station to a fixed location, like a home, business, or government facility. The devices at each end, transmitter and receiver, don't balk move, hence the term fixed.
And instead of relying on wired connections like copper or fiber, fixed wireless uses microwave or millimeter wave radios, licensed or unlicensed spectrum, and line-of-sight or near line-of-sight paths.
This makes it a powerful solution for areas where running fiber is too expensive or physically impossible. Think mountains, farms, or remote industrial sites. So, how does fixed wireless work?
At the core, you have a base station, often mounted on a tower, rooftop, or water tank, which beams a high-frequency signal to a customer premise equipment CPE antenna. Some providers are now deploying fixed wireless solution in metro areas.
The CPE connects to a router, just like any broadband service. From there, users get internet access with speeds that can range from 25 Mbps to over 1 Gbps, which depends on spectrum, hardware, and distance.
And many modern systems support QoS, quality of service, VLAN tagging, and low latency protocols, making them viable for enterprise connectivity and even voice or video transmission.
There are several types of fixed wireless tech. Licensed microwave links, great for dedicated long-haul connections up to 40 miles with strict interference protection. Unlicensed point-to-multipoint, cost-effective, scalable, ideal for local ISPs or rural deployments. Millimeter wave, high throughput, multi-wave over short distances, often used in dense urban environments. And CBRS, Citizens Broadband Radio Service, mid-band, and shared spectrum in the U.S., giving smaller providers a more reliable and affordable license option.
So why consider fixed wireless? Lower deployment costs compared to trenching fiber. Rapid rollout, especially for rural broadband initiatives. High scalability, can support hundreds of users per tower. Fiber-like speeds with newer technologies like MIMO, links exchange segment, and backup connectivity for primary broadband links, SD1 failover.
It's also great for disaster recovery, pop-up locations, or temporary sites like field hospitals or construction zones.
Can fixed wireless substitute fiber in remote access cases? Absolutely. Especially when latency-sensitive applications aren't mission-critical or when last-mile fiber is cost-prohibitive.
In fact, a hybrid model is common: fiber to the tower or fiber to the nearest point of presence, then wireless to the endpoint. This gives you the best of both worlds, high-capacity backhaul with flexible access.
Of course, it's not all perfect. There are some technical and logistical hurdles. Capacity limits, shared spectrum can cause congestion during peak hours. Distance degradation, signal strength and quality drop off quickly over miles, especially in unlicensed bands. Line-of-sight dependency or trees, buildings, or hills can block the signal path. And roof rights and mounting. Getting permission to install antennas on private or commercial property can be a legal nightmare.
And don't forget weather. Heavy rain or snow can impact signal quality, especially in higher frequency bands like 60 gigahertz.
So fixed wireless is evolving fast. The large wireless providers, AT&T, Verizon, and T-Mobile, now offer fixed wireless access, FWA, leveraging mmWave and massive MIMO. There is AI-powered beamforming for signal optimization. Mesh backhaul topologies can extend coverage without using fiber. And providers are now integrating SD-WAN and hybrid cloud architecture into fixed wireless architecture.
And as more spectrum becomes available, like CBRS and 6 gigahertz, we will see increased competition and lower costs, making fixed wireless an even more attractive option for enterprise and residential markets. Any final thoughts?
Yes, fixed wireless isn't trying to replace fiber, but in many cases, it's the only practical alternative for delivering high-speed internet to hard-to-reach areas.
Whether you're an ISP, IT director, or rural community planner, it's a tech worth understanding and possibly investing in.
That's it for today's episode of Technically You. Hit that subscribe button and let us know, do you trust fixed wireless to replace your fiber connection?
Thanks for tuning in. Stay connected, stay informed, and stay curious.